organically increases its own cardiac output when it needs it, which I think is just pretty cool. So that's blood vessels. We did that in 9 minutes. We will try and rock it through the lymphatic system without being nonsensical. So what your lymph does is two important things. One, it returns blood that has leaked out of your capillaries. Fluid that is leaked out of your capillaries gets returned to your circulatory system, back to your blood vessels. So your capillaries have relatively high pressure because they're being fed by arteries, and they're very permeable. There are small holes and gaps in the epithelial wall that allow fluid to actually leak out of your blood vessels. So now we're going to go through some of these specific lymphatic tissues. And we're going to go through them really quick. Again, the lymphatic system we don't cover very deeply, and I don't want to take too long for this. So the lymph nodes you can find throughout your body. And what we saw up here, whoops, I went back too far. This is what a lymph node looks under the microscope. And this is where you find them all over your body. There are 4 major accumulations of lymph nodes. You have your inguinal nodes, your axillary nodes, your cervical nodes, and then you have a lot of them in your abdominal region. But actually it's 3, I miscounted talking so quick. The 3 major superficial accumulations of lymph nodes is inguinal, axillary, and cervical. But you do have quite a few in your abdominal region. They're just not close to the surface. So one of the things the doctor is checking for you when he says he's checking for swollen glands is the lymph nodes in your cervical region to see if you're fighting a cold and lots of virus or bacteria is getting into the bloodstream there. Then those lymph nodes are going to swell up, because that's what happens when your immune system kicks in. I don't know if we've talked about it before, but if you do actually have an infection, inflammation is a good thing. We don't like the pain that comes with it, so we tend to think of inflammation as a bad thing, and we want to get rid of it as soon as possible following an injury. But when you have an infection, you want inflammation. We'll talk about that more when we do the immune system. Lymph nodes. So the lymph nodes, as it says here, do 2 important things. Filtering is the physical process of just removing the stuff that's not supposed to be there. And then the cells that are doing the filtering are part of your immune system. So your lymph nodes are actively filtering and fighting any possible infectious agents. We are going to skip over this slide. This is technically some anatomy that you're supposed to know in lecture, but I never put a picture on the lymph node on the exam, so we'll skip right over it. Which also means we can skip over this. It's just a very nice picture of a lymph node with all of the follicles and the connective tissue capsule around the outside of it. I think we can skip this as well. I don't usually ask about this stuff. The important thing, actually, I take it back, moving too quickly. This last line here that is underlined is important. I don't always ask about it, but it's an important concept to get down. So you have lymphocytes and other cells that are housed within your lymphatic system, but they don't always necessarily stay put. So one particular T cell might spend, I don't know, a day or 2 in one of your lymph nodes, and then let go, float through the lymph into the bloodstream, circulate around, and show up in another lymph node somewhere else. This becomes important when we think about the fact that our immune system is just that. It is systemic. So that when you learn how to fight an infection, a virus or a bacteria, you can fight that infection wherever it shows up, because the cells of your immune system that have been educated against that specific virus or that specific bacteria don't just hang out in the lymph node where they first encountered it. They circulate. So your immunity circulates as well. The spleen, I forgot to put in the link to the What Does the Spleen Do video. I'll show you guys that later in class if you haven't seen it already. We talked about it when we did blood in one of the sections. At any rate, what's underlined here is the important part of what the spleen does. It removes dead red blood cells from the circulation. I will say no more about that. The spleen filters dead red blood cells from your circulation. This is what it looks like. You'll never see a slide of it either on the practical or in lecture. The thymus is interesting. It would be nice if we had more time to talk about it. It is where your T cells mature. So as you grow and your T cells are generated in your bone marrow and your immune system develops, they get tested in your thymus and then they get released into the wider circulation. And as the amount of T cells that you have increases, your thymus gets smaller because your body is producing fewer of them. So by the time you are a fully grown adult, you're done producing T cells and your thymus starts to atrophy. This is why the thymus isn't on the models in the lab, because the models are adults and the thymus just doesn't show up in adults. Tonsils. The tonsils are little lymphatic organs or patches of lymphatic tissue that you find around your pharynx, which is the back of your throat. Wherever you have a common passageway for both food and air, it's referred to as pharynx. And then when that splits, you get your trachea and your esophagus. So what this essentially does, or one of the things it does, is sample environmental pathogens that are passing through you. So if you, let's say, eat a well-cooked hamburger, any bacteria that might have been in that hamburger are dead and not a threat to you, but some of that might make it into the tonsil. And your immune system can still take that bacteria apart and study it. And even if some of the bacteria in your food are still alive, they're going to end up dead once they make it to your stomach. So most of the time the bacteria that you eat or the viruses that you eat don't kill you because they end up in a pit of acid, which is your stomach. But your tonsils, this lymphatic tissue, can get exposed to these bacteria and these viruses, and it's a way for your immune system to get a sneak peek at what's in the environment before it gets in your bloodstream. Because as long as it just ends up in your stomach, most of the time it's not going to hurt you. Obviously there's like food poisoning and stuff, but your stomach does a pretty good job of killing any bacteria that end up in it. Then you have your appendix. It's not exactly entirely clear what the true role of the appendix is. It is this little thing right here. It's a little finger-like extension, as it says, from the large intestine, and it's got a ring of follicles surrounding the lumen. It is generally filled with bacteria, and it used to be thought that your spleen helped kill any bacteria that made it through your small intestine. It is now thought, although this isn't like the total new scientific consensus, but one of the current theories being put forward for the function of the spleen is that it actually acts as a reservoir of good bacteria for your gut. Now you think about probiotics and yogurt and these natural products that you're supposed to eat because they contain the good bacteria. Well, your body keeps a little stash of it in your intestine so that if you have something like the flu, not your intestine, your appendix, if you have something like the flu and you've got, let's say, diarrhea for 2 days, you're pretty much flushing out everything that's in your colon, and you need to replenish your natural bacterial flora somehow, and it's thought that that might be what your appendix does. And then you have lymphatic tissue in lots of your other organs, which we won't necessarily talk about, but it's fun to kind of look for as you go through the rest of anatomy and physiology too. Every once in a while you'll be in some completely non-lymphatic organ and see a few follicles of lymphatic tissue. These two, where are we? Peyer's patches we haven't talked about yet. We have talked about the appendix. Peyer's patches are an example of that diffuse lymphatic tissue where you have clusters of follicles inside the wall of your small intestine. I am not at all sure what Peyer's patches do. They might be there to a certain extent to help regulate your body's reaction to things that pass through your gut. So think about people that have irritable bowel syndrome or gluten sensitivities. That happens because your immune system is active in your gut. And well, I won't say too much more about it because I don't really know too much more, but just know that you have some lymphatic tissue in your gut, which means your immune system is present there. And where'd we go? This is, so here's your small intestine. This is all the mucous membrane that's absorbing all of the food that flows through your small intestine. And here are all of these lymphoid follicles in the wall of small intestine. All right, that's blood vessel and lymphatic, under 30 minutes. If you're still listening, thanks for sticking with me. See you after the break.